Hey, so in this video, I'm going to show you the process and thinking behind SIG number 13, which is on velocity acceleration applications. All right, so first thing is problem number one here. A particle moves along a horizontal line. Its position function is shown way below. It's down at the bottom. T is greater than 0 for each problem. I need to find the velocity function. Okay, so let's go look at our function. Our function is s of t. It's down here. S of t equals negative 2 to the third plus 14t squared. All right, so s of t equals negative t cubed plus 14t squared. I want to find the velocity, which is just going to be s prime. The derivative of the position tells me the velocity, right? S prime of t is going to be the velocity, which is going to be negative 3t squared plus 28t. So this is my velocity function right there. This is velocity function. Next, I want to find the velocity function, the acceleration function. We're on part B now. The acceleration function is going to be the derivative of the velocity. So if I take the derivative of my velocity function, I will get the acceleration function, which is going to be negative 6t plus 28. All right, this is my acceleration function. If I want to know the acceleration at any given t, all I need to do is plug in those t values and I'll know the acceleration. Part C is asking, find the times t when the particle changes direction. So the idea here is that if you're moving in a certain direction, in order to go back the other direction, you first have to stop. So I'm looking for, the only place it can change direction is where it stops. So I'm looking for where does it stop. If something's going to stop, then its velocity is going to be 0. So I'm going to go up to my velocity function. And I'm going to say, well, when is it 0? Not when the t is 0, but when is the actual velocity 0, right? So when is this piece equal to 0? And I'm going to try to solve this, right? The way we can solve it is factor out a t, and we will get negative 3t plus 28. And so there are two places where this will equal 0, which is t equals 0. That came from this one. And another place is when negative 3t plus 28 equals 0, which is when t equals 28 over 3. All right. So those are the two places. I'm not guaranteed that they actually change direction there. So I actually need to start with 0. 28 over 3, and I need to try some different numbers in here. Right, so let's imagine I plug in a number over here, like a negative 1 or something. If I plug that into my velocity function, I'm going to have a negative out here. I'm going to get so let's just plug in negative 1 wherever you want. But if I plug it on the top, I'm going to have negative 3 plus negative 28. That's definitely going to be negative, right? So over here, our velocity is negative. In between 0 and 28 over 3, pick a number. 28 over 3 is, real close to 9, a little less than 9, so a little more than 9, so you can pick anything in between. Why don't we just try like 5 or something, right? If I plug in 5, it'll be 5 squared, 25 times negative 3, it's negative 75, plus 5 times 28 is 140, and you can see that the positive term is bigger, so we're going to get a plus here. Now if I plug in something bigger than 28 over 3, such as like 10, right? If I plug in 10, let's actually do this math so you can see what we're doing. It's going to be 3 times 10 squared plus 28 times 10. This is going to be 10 squared is 100, negative 300 plus 280. And you can see now the negative term is larger, so we're going to get a negative. So yes, it changes directions. It changes directions at t equals 0 and t equals 28 over 3. And I need to show this work over here to prove it, because there are certain cases, maybe not on this particular problem, but there are some on these sig tests that will be that they don't change directions. All right, so now I need to write the intervals of time when the particle is moving left and moving right. We already did most of this already. So it's moving left when the velocity is less than 0, and it's moving right when the velocity is greater than 0. And I already figured all this stuff out, right? It was less than 0 from, so let's write this, left. It was less than 0 from negative infinity until I got to 0, and it was negative from 28 over 3 to infinity, right? That's when the velocity was negative. Now, when was it positive? It was positive from t values between 0 and 28 over 3, right? Part E here is find the times when the acceleration is 0. This means we need to take our acceleration function, which is negative 6t plus 28. Right, our acceleration is negative 6t plus 28. We need to set it equal to 0. And we will get t equals 28 over 6. Simplify a little bit, we can get 14 over 3. That is when the acceleration is 0. Okay, last thing here is the intervals of time when the particle is slowing down and the other interval where the time is speeding up, right? So the answers here are, oh, it's slowing down in these intervals, and here it's going to be speeding up in these intervals, right? So slowing down is when the acceleration and the velocity have different signs. You don't need to write this on yours, I'm just trying to show you what it is. And here is when acceleration and velocity have the same sign. Right, so I already have the chart for velocity. I need to make another chart for acceleration. Right, let's go back up here and look at this. This was my velocity chart. Let's make one for acceleration. I need to basically, I can just draw this same line, and 14/3 is where my acceleration could possibly change. So I should check left of 14/3 and right of 14/3, right? If I'm left of 14/3, I'm going to plug it into my acceleration function. Then anything less than 14/3, the 28 is going to be bigger, and I'm going to get a positive number. So here it's positive. Anything right of 14/3, this 6t term is going to be bigger, right? You're going to multiply it and it's going to be a higher number, and so you will get a negative because you'll add it to 28 and you get a negative. So basically I'm looking at this and saying, well, on what intervals are my signs the same? And as you can see, from basically negative infinity to 0, right, my velocity was negative and my acceleration was positive. Opposite signs. So I would say that it was slowing down from negative infinity to 0. Okay, and then we keep going from 0 until 14/3. The acceleration is positive and the velocity is positive. So here I'd say from 0 to 14/3. Let's write that a little bit neater. My acceleration was positive. And then I keep going and I say, okay, from 14/3 until 28. Now my acceleration is negative and my velocity is also negative. Sorry, my velocity is positive. See, we're still in the positive region over here. And so those are opposites. So we'd say from 14/3 to 28/3, it was slowing down, right? So 14/3 t 28/3, and then we keep going, and from 28/3 and on, there's nowhere to stop. They're both negative, which means since they're the same sign, it means that they're increasing. So this is from 28/3 to infinity. It was speeding up, right? And that's how that one goes. Okay, let's look at problem number 2. It's asking a particle is moving along a vertical line this time. Doesn't really matter which way it's whatever. It says find the displacement of the particle. The displacement is this. You got to think about it as this thing where it's 2 steps forward and then you take 1 step back. Your displacement is 1 because you are only 1 step away from where you started. So the displacement is how far away from where you started are you, right? Whereas distance in part 2 is if I go 2 steps forward and 1 step back, the distance is how far total did I go. Well, how many steps total did I go? Well, I took 2 forward and 1 back. So the distance in that case is 3, whereas the displacement was simply 1, right? So you have to think about that. If I ever go backwards, then my distance will be different from my displacement. So to find the displacement, all you have to do is find the change in position. So all you simply do is it's the top part of the slope of a secant line problem is simply s of b minus s of a. It's the difference in position, the change in position. So it's going to be s of 11 minus s of 0. Why am I using 11 and 0? Well, those are given to me in my interval down here. And if I do this, it's going to be, plug in 11, you get 11 to the third minus 8 times 11 squared minus, plug in 0, you're just going to get 0. And so 11 to, and 11 to the third is a little bit hard to do, but it's not impossible. We know 11 squared is 121. You just got to multiply it by 11, and you will get 1331 minus 121 times 8 is 8, 16, 9, 968, and then you do one more little algorithm and you get 3, 6, 3. So the displacement was 363. Right? Now the distance, we have to take into account the fact that we may have gone up and then back again. So the way we figure this out is, well, if I did change directions, think about what that says. Is if I'm changing directions, what has to happen? Well, the velocity has to equal 0. So to figure out if it changed directions, I need to determine if the velocity was ever 0. So I'm going to find the velocity function and set it equal to 0. And we're going to get 2 solutions here. We're going to get t equals 0 and t equals 16/3. So the 0, 1 doesn't matter because that's where we started, so you can ignore that. And then 16/3, it changed directions at 16/3, which means what I need to do is I need to break my interval into 2 pieces. I need to go from s of 16/3 and take the absolute value because I don't want any negative numbers really, right? S of 16/3 minus s of 0, and then I'm going to add that to the rest of the interval, which is all the way to 11, right? S of 11 minus s of 16/3, right? It's breaking it into 2 different pieces so that you can find the distance on this, and you will be allowed to use a calculator on this one, so you can just calculate these distances on your calculator and get the answer.